Hello, geometry class. This is the notes for chapter 6, section 1. What we've been talking about a lot has been congruency of segments, congruency of angles, congruency of triangles. We talked about a lot in chapter 5 about some of the properties of things inside of triangles. So we're still going to be talking about triangles, but it's a little bit different now. We're talking about some similarity in this chapter. So similarity means there's something connected with them, there's something the same with them, but they're not congruent. All right? So if things are similar to each other, we're going to be talking about ratios. Okay? So a ratio is just a comparison of two numbers, A to B. It is usually written in simplest terms, meaning you've canceled out some common factors. So, wording. When we say a ratio of A to B, we're talking about a fraction. It's one way it can be written. And the order kind of matters. When we say ratio of A to B, that first number goes in the numerator, second number goes in the denominator. All right. Now, sometimes it's written like this, with the colon, A to B. It means the same thing, but the most useful is the fraction. So, in this example, it says write the ratio of A to B and B to A. So we just got these rectangles. They're similar to each other. When we write a ratio, we're comparing corresponding things. So the heights on these two rectangles, 20 and the 10. So when it says ratio of A to B, that's going to be 20 over 10. And like I said before, ratios are usually written in simplest terms. 20 over 10 can be simplified down to 2 over 1. Now, it doesn't matter which corresponding things. If the objects are similar, we do 9 over 4.5, that's still the same. That's 2 over 1. Okay, so it shouldn't matter which side you use as long as they're corresponding sides. The ratio for B to A, well now the stuff from B goes first. So 10 over 20, which is a 1/2. So we're still comparing the same two things. You know, we're going from 2 to 1 or 1 to 2, whether we're going from A to B or B to A. So it's the same ratio, it just depends on which one you're going to first. And same thing, you could have 4.5 over 9, which is still 1 over 2. Okay? This bottom example, it says simplify the ratio. Notice we're talking about two different units of measurement. When you are comparing things in a ratio, you should be looking at the same quantity, same meaning of the quantity. So what we want to do is convert these things. Okay, 36 inches, that's 3 feet. So 3 feet compared to 9 feet, we're talking about 3 over 9, which is 1/3. Now the question over here on the right says, does it matter which units you convert to? Well, I don't know. 36 inches compared to 9 feet is 108 inches. So if we do 36 over 108, that's still 1/3. So it doesn't matter which units you convert to, just get them to be the same units. All right, and whichever one is easier to convert to, probably 36 inches into 3 feet. That's probably quicker. I mean, it doesn't matter, but just get the two numbers into the same units. All right. An example of a problem that you'll see is given these ratios of objects, whether they're side lengths or angles, as in this example here. In this one, it's an extended ratio, meaning we're comparing two things. So that 2 to 3 to 4, we can compare any two of them. 2 to 3, it could be 2 to 4. We also have a 3 to 4. We're just given all three of them as a ratio, but it can give us 3 different comparisons, 3 different ratios. But the idea here is, again, ratios are assumed to be in simplest form, meaning there could have been a common factor that was canceled out. And that's what the case is going to be here for this one. You know, we don't have angles of 2 degrees, 3 degrees, and 4 degrees. Okay, that's not going to give us a triangle because 2 plus 3 plus 4 is not 180 degrees that the angles of a triangle should add up to be. So the key to this problem is what is that common factor that was canceled out? We're just going to throw an unknown factor of x on there. So one angle was 2x, one angle was 3x, another angle was 4x. X being that common factor. Okay, and if you think about it, if you throw that x on there, you look at this ratio right here, 2x over 3x, x is a common factor, it simplifies out, and we're just left with a 2 over 3. Okay, so all we're doing is just attaching that common factor of x. So now, find the measures of these angles. Well, these are the three angles of a triangle. They add up to be 180 degrees. So 2x plus 3x is 5x, plus 4x is a 9x, that's 180. Divide both sides by 9, we got x is 20. So that common factor that got canceled out of each of those angle measurements was 20. That means the angle was, well, 2 times 20 is 40 degrees, 3 times 20 is 60 degrees, 4 times 20 is 80 degrees. There's 3 angle measurements for this triangle. Okay, so when there is that unknown common factor, attach it. It's just your variable x. All right, so ratios are just a comparison of two numbers. It's a fraction, one number divided by another number. A proportion is an equation that says these two ratios are equal to each other. To solve a proportion, like it says, you're going to cross multiply. Okay, the idea of a cross multiplication is it gets rid of the fractions, it gets rid of those ratios. So, cross multiplication, you're going to take one denominator, multiply it by the other numerator, take the other denominator, multiply it by the other numerator. So we got 8 times 27 to equal 24 times x. All right, that's the idea of cross multiplication. We had two fractions that were equal to each other, that was our proportion. To solve for the variable, it doesn't really matter where the variable is in this proportion, you just cross multiply. That will always work when you have a fraction equal to a fraction. So now to solve for x, we're going to divide by 24. That cancels that out, we're just left with x. All right, so now we can just do 8 times 27, which is a bunch, 160 plus 20, or plus 56, so it's a whole bunch, divided by 24. There's an easier way to do this. Okay, you can do this 8 times 27, then divide by 24, but 27 is 3 times 9, 24 is 3 times 8. Common factors cancel out. All we're left with is 9. It's a nice little math trick to get rid of higher numbers, multiplication and division. For this example here, same thing. It's a fraction equal to a fraction, so we're dealing with a proportion. To solve it, cross multiply. So 2 times 4x is 8x. That will equal x plus 3 times 5. With this, we got to do some distributive property. 5 times x plus 5 times 3. That equals our 8x. So now to solve for x, we've got to move all the x's onto one side. So I'm going to subtract 5x from both sides. That gives me a 3x equal to 15. Divide by 3, x is 5. Okay, so that's solving for x. Now, just to make sure that this is a good answer, we can always plug in x. 2 over. If x is 5, we got 5 plus 3, that's 8. Does that equal 5 over 4 times the x value of 5 is 20. 2 over 8 is the same thing as 5 over 20. They're both 1/4, so it works. All right, the last thing that we're going to talk about here in this video is a different type of average. It's called the geometric mean. Now, when you see that word average, what you're doing is taking your two numbers, adding them up, or taking your numbers, adding them up and dividing by how many numbers you have. Okay, that's the normal, that's average. So we got 40 over 20, that is, or 40 over 2, which is 20. So when you hear that word average, you're adding numbers up and dividing by how many you have. A geometric mean is a different kind of average. It has a different meaning and it's a different process. And I'm giving you two examples here. Geometric mean between 4 and 9, it's 6. The geometric mean between 6 and 24 is 12. So you can see we're definitely not adding. 6 plus 24 is 30. You divide by 2, that's 15. It's not 12. All right? So the geometric mean is a little bit different. What we're going to do to go from 6 to 12 to 24, well, you're multiplying by 2. To go 6 times 2 gives us 12. 12 times 2 gives us the 24. All right? So the geometric mean is actually a common multiplier. What are you multiplying by to go from the first number to that geometric mean and then to the last number? All right? That's the difference here. 4 times 1.5 gives us the 6. 6 times 1.5 gives us the 9. So 6 is that geometric mean between 4 and 9 because there is that common multiplier taking us from one number, first number, to the geometric mean to that last number. Now, to get that formula or to get that number, what you're doing is really dealing with a proportion. And this, when the question is just what is the geometric mean, that's your formula. You're multiplying the two numbers and then taking the square root. 4 times 9, that's 36. So you take the square root of 36. There's where that 6 came from. 6 times 24, you take the square root of that. 6 times 24 is 144. Square root of 144 is the 12. All right, so this is geometric mean. It's a different form of an average. Averages are dealing with the normal word average, like I wrote up here. That's dealing with addition. Geometric mean, we're talking about multiplication, but you take the square root of the product. Okay, that is all. Bye.